deal with the devil parameterized complexity is based on a deal with the devil of intractability such as illustrated in Figure 1.3. We regard as a worthy goal a combination of good and bad complexity behavior, where the main part of the problem contributes to the overall complexity in a good way, e.g. polynomially, but some aspects of the input, the parameter, may contribute poorly to problem complexity. We regard this outcome as acceptable since we are hoping to confine the parameter to some small but still useful range. As illustrated in Figure 1.3, the deal we attempted to cut with the devil is one that confines the inevitable combinatorial explosion, which we expected for interesting problems, to some limited aspect or distribution of the problem. At this point, it is worth remembering the happy outcomes of the story of Dr. O. Since Dr. O is concerned only with the parameter values k in the range k which is less than or equals to 50, we have been able to deal entirely and completely with the NP completeness of the data cleaning problem for input data set of unlimited size. The moral of the story is that classical complexity frameworks such as NP and p-space completeness are not adequate to address intractability questions for problems that are parameterized and for which important applications are covered by small ranges of the parameter. The formal setup of parameterized complexity theory is based on the following reworking of the foundation definitions. We consider the input to a problem as consisting of two parts and thus as a pair of string x, y, which is in sigma star multiplied by sigma star. We say that y is a parameter. As in the classical setup, it all boils down to recognizing the yes instances. We define a parameterized language to be L, which is the subset equals to sigma star multiplied by sigma star. This is what makes a parameterized complexity fundamentally different. The input is considered to be two-part, and the target of our efforts is a viable dialectical combination of good and bad. We regard this formulation as an inevitable response to the fundamental empirical fact of ubiquitous computational intractability in the world of natural computational problems. In the same way that the notion of polynomial time is central to the classical formulation of computational complexity, central to parameterized complexity is the notion of fixed parameter tractability. Here we are considering languages that are tractable by the slice. Definition 1.1, fixed parameter tractability. A parameterized problem L, which is a subset equals to sigma star multiplied by sigma star, is fixed parameter tractable if there is an algorithm that correctly decides for input xy, which is in sigma star times sigma star, whether xy is in L in time f of k times n to the alpha, where n is the size of the main part of the input x, and the absolute value of x equals to n. K is the parameter which we can take to be the length of y. K, which is the absolute values of y. Alpha is a constant independent of k, and f is an arbitrary function. What the above definition accomplishes in generalizing polynomial time is the following. 1. The complexity contribution of the parameter part of the input is turned over to the devil, who contributes to the overall complexity of the problem, the arbitrary function f of k. 2. The main part x of the input of the problem contributes to the overall complexity polynomially as n to the r. 3. The connection between the two contributions is specified to be multiplicative. The overall complexity is f of k times n to the r. One of the interesting and fundamental properties of fixed parameter tractability is that the definition is unchanged if we replace 3 with 3 prime. The connection between the two contributions is additive. The overall complexity is f of k plus n to the alpha prime. More about this can be found in section 2.1 and 2.2.